Hello everyone. In this video I will be discussing Learning Objective 4 of week 6. The Learning Objective 4 is perform basic data transformations. So the background is, when we collect data and we organize the data, it's not necessary that the raw data that we collect will always be useful for numeric analysis. That's why sometimes we need to transform the original data into a form that is suitable for numeric analysis. That's called data transformation. So original data transformed into a form that can be used for different statistical and numeric analysis. Just look at this example first. I am satisfied with my college experience. So there are 5 alternative answers: strongly disagree, disagree, neutral, agree, and strongly agree. So 110 respondents provided strongly disagree, and 210 respondents provided a strongly agree answer. 30 disagree, 35 agree, and 15 neutral. So these 5 alternative answers, although you get that, you can see that these 2 answers, that is strongly disagree and strongly agree, are the most common. Okay, so if we look at this, it's actually a sort of bimodal distribution, because 210 and 110, so almost 80% of the answers are coming from strongly disagree and strongly agree. Now if we can transform these 5 scale answers into a more shorter scale answers, look, if we add this 35 to 210 and 30 to 110 and combine these 3, strongly disagree and disagree, and just say disagree, and agree and strongly agree can be combined and titled as agree. And if we just remove these 15 neutral answers, then this 5-point Likert scale answer can be reduced to 2 nominal answers: agree and disagree. So it might be now more easier to represent this distribution since it's a bimodal distribution. Okay. So this is particularly possible when you have a bimodal type of distribution. Now what we do is, to make this sort of data transformation, we do a median split. Okay, so median split means if we have a data set, and you know that median, we learned it in the last class, that median is the midpoint of data. So half of the data should be below the median and half of the data should be above the median. So if we have a bimodal sort of distribution that we have just seen, then we can go for a median split. So median split means we divide the data from the median, and all the observation below the median will be considered as one response, and all the data above the median will be considered as one response. So maybe a 5-point or 7-point Likert scale data collapsed into 2-point answers. So that makes the data analysis or interpretation easier. Now the question is this median split is always working? Look at these answers. The question was, I do most of my shopping at convenience stores. So respondents were asked to provide alternative answers like strongly disagree, disagree, slightly disagree, slightly agree, agree, and strongly agree. So there were 6 alternative answers, and you can see 10 answers were strongly disagree, 40 disagree, 125 strongly disagree, 125 slightly agree, 40 agree, and 10 strongly agree. Now, is it possible we do the similar median split and we collapse these 6 answers into 2 answers? So probably some of you are thinking that we can combine these 3, strongly disagree, disagree, and slightly disagree, and we title it only disagree, and we sum up is slightly agree, agree, and strongly agree together, and we call it agree. So the 6-point answers become 2-point answers. However, the problem is, if you look carefully, 125 answer are strong, slightly disagree, and 125 is slightly agree. Now this 125 slightly disagree. So when the answer is slightly disagree, it means that they are slightly agree as well. And 125, those are slightly agree, those are slightly disagree as well. Now, what do you think? Adding this slightly disagree with strongly disagree, is it a good idea? And slightly agree with strongly agree, is it a good idea? Or adding slightly disagree and slightly agree together is a good idea because they are both slightly agree and slightly disagree. So probably it will not be a good idea to divide it from the median and add these three and add these three. Rather, probably we can add strongly disagree and disagree, slightly disagree and slightly agree, and agree and strongly agree. So instead of collapsing it into 2-point answer, we can collapse it into 3-point answer. So the main point I want to make you clear here, that median split may not work all the time, particularly if it is not a bimodal distribution. Now index numbers. Index number is another way of transforming data into a useful manner. Probably you might have familiar with some index number. For example, we say consumer price index, sometimes we say stock price index. So index number is basically transforming each observation related to a base observation, okay, so that it becomes easier to compare. Look at this example. Weekly television viewing statistics are shown here. A base number is selected. The US household average of 52 hours and 36 minutes represent the central tendency and will be used. That means on an average, US household watch 52 hours and 36 minutes they watch television. Now we have three groups. One is 1-person household, 2-person household, and 3+ person households. US average is 52 hours 36 minutes. 1-person household watch 41 hours, 2-person household watch 47 hours, and 3+ person household watch 60 hours, and 52 is the average. So what we are doing here, each observation is divided by the base observation, 52 hours 36 seconds, that's the base observation, and multiplied by 100. So this one divided by the average multiplied by 100, this one average by the divided by the average multiplied by 100. So now what we get is the index number. Okay, so for 1-person household it's 78.32, for 2-person household it's 90, for 3+ person household it's 115, and US average is 100. So you understand that what previously was 52 hours 36 minutes is now transformed into 100, and what previously was 41, 47, and 60 are now transformed into 78, 90, and 115. So you might wonder that what is the purpose? The purpose is ease of comparison. Now look that US average is 100 and 3+ person household watch 115. So you can easily say that a 3+ person household watch television 15% higher than the US average. And it's 90.87. We can say that 2% household watch television 10% less than US average. So this is how index number helps us comparing the observations. This is rank order. Rank order is another way of summarizing our transforming data that actually involves multiplying the frequency with a particular scale. Look at this example. Here, 10 executives working in an organization were asked to rank 4 places where the next annual general meeting of the company could held. So they were asked that which location they chose most. These 4 locations are Hawaii, Paris, Greece, and Hong Kong. So executive 1 ranked Hawaii first, Paris second, Greece 4, and Hong Kong 3. Executive 2 ranked Hawaii first, Paris 3, Greece 4, and Hong Kong second. For example, executive 10 ranked Paris first, Hawaii second, Greece third, and Hong Kong fourth. So in this way, 10 executives ranked these 4 places from their top to bottom choices. Now they are summarized how I got 3 first choice, 5 second, 1 third, and 1 fourth. Paris got 3 first, 1 second, 3 third, and 3 fourth. So this is how they have been summarized. Now what's done is, you can remember how I got 3 first, so 3 is multiplied by 1, 5 seconds, so 5 is multiplied by 2, 1 third, so 1 is multiplied by 3, and 1 fourth, so 1 is multiplied by 4. So they are multiplied and they are summed up. So how I got a composite score of 20, Paris 26, Greece 26, and Hong Kong 28. So since we are multiplying the number with the priority, so the lowest score indicates the most favorable place. So Hawaii got lowest score 20. It means that Hawaii is the most attractive place among the executives for their next annual general meeting. So this is the rank order. That's another way of transforming data. Pie chart. This is a way of presenting data which might be more useful for the readers sometimes rather than presenting the data in a tabular format. Look at these 3 pie charts. It's showing beverage preferences in 1992, 2005, and 2008. For example, in 1992, you can see beer was the most preferred one with 47% preference, spirit 21%, wine 27%, and other 5%. So from 1992, as we move to 2005, we can easily see that the popularity of wine has increased substantially. For example, 27% to 39%. However, beer has lost its popularity, whereas the spirit remains almost the same. Now, as we move to 2008, once again, we see that beer has regained its popularity to some extent, and wine has lost its popularity once again, but spirit and others are still the same preference the respondents have. So you can say that sometimes rather than presenting a lot of numbers in a table, if we present some pie chart or bar diagram, so probably that will be more easier for the readers to comprehend the information we want to provide. So this is the end of this video. In the next video, we will be discussing learning objective 5 and 6 of week 6. Thank you.